It is given that three discs A, B and C have radius 2 meter, 4 meter and 6 meter respectively are coated with a carbon black. That means we can just take it as something but like black body or emissivity as 1 on their outer surfaces. Wavelength corresponding to maximum intensity are 300 nanometer, 400 and 500 respectively. The power radiated by them are QA, QB and QC respectively. So we can just consider a disc shape object over here. So let's say the area of disc shape object is nothing but A, and if its radius is R, we can write this area will be equal to pi r square. Like that, it is having two surfaces. Over here also we can take it as area is equal to pi r square. And let's say its temperature is nothing but T. So we know the equation for the amount of heat energy radiated by this object. So we can write the value of dq by dt. Over here it is represented by Q is equal to, we know that E sigma A, temperature of object raised to 4. According to this question, we can write this E into sigma into area. Over here it is total surface area is upper surface plus the lower surface. That is 2 times of pi r square is a value of total surface area into T naught raised to 4. So we can take it as object temperature of object raised to 4. But in question, the wavelength correspond to maximum intensity radiation is given. So from Wind's displacement law, we know that T is inversely proportional to the value of lambda. So by using that, we can write this Q is directly proportional to, over here the parameters which are varying are radius. So we can write r square and T raised to 4. And T is inversely proportional to lambda. So we can write this r square into 1 by lambda raised to 4. Or you can write this Q is directly proportional to r square and lambda raised to 4. So we can find out what about the ratio of heat energy emitted in different situations. Like if you just want to find out the value of QA, QB and QC. So we can write, so for Q is directly proportional to r square by lambda raised to 4. We can write in the QA situation or first situation, radius is given as something but 2. So we can write as 2 square divided by wavelength is something like 300 nanometers. So we can take it as something but 3 raised to 4 is 2. For second situation, radius is given as something but 4. So it's 4 square divided by, it is given as wavelength is 400. So we can write as 4 raised to 4 is to, in the third situation it is given that 6 square divided by wavelength is given as something but 5000. So we can take a 500. So we can take it as 5 raised to 4. They will be in this ratio. So we can identify the value for it. So it is something like 2 raised to 2, which is 4, divided by 3 raised to 4, which is 81, is to this 4 raised to 4 and this one get cancelled. So we can write as 4 raised to 2, that is 16. And the third one we can write it is something like 36 divided by 5 raised to 4, which we can take it as about 625. So if you are further calculating, you will get the answer for this as something like 0.0493, and this is something like 0.0625, and next one it is something like 0.0576. So we can say that this QB is having the maximum value, then we have QC, then we have QA. So we can write this QB is greater than that of QC, which is greater than that of QA.